So in today's video we'll discuss three-phase transformer. I am not quite hopeful that I will be able to cover it in a single video. Rather, I have what I anticipate that I have to make many videos on this single topic. This is a very important topic. So three-phase transformer. What about a three-phase transformer? How to understand a three-phase transformer? What is the difference you can figure out with single-phase transformer, or rather you can figure out between a single-phase transformer and a three-phase transformer. In case of a single-phase transformer, other than means having two different polarity, like having additive polarity and subtractive polarity, you do not have much choice to change the phase of your secondary analysis. So if you have not studied that one, please do not watch this video. Otherwise this video will you will find this video extremely difficult to understand until unless you have a proper understanding on three-phase balance circuit. What is star, what is delta, how they are related, how their connection patterns takes place. So here in three-phase transformer, what we can have other complete three-phase transformer, like the whole transformer will come to us as a single unit. We will have three primary terminal and three secondary terminals. Anyway, before going to three-phase, let me describe a few common notion that in case of three-phase we can have either three-wire or four-wire connection. So what is three-wire and what is four-wire? If you connect all your winding or whatever your means all your phase circuit in delta, then you will have three-wire connection. Now, even if you do not connect your phase element in delta, you connect them in star, like this, and connect a load in this way, then it is also a three-wire connection. But if you connect your neutral with the load, then it is a four-wire connection, because you are connecting with four-wire. Now those who have already studied this star delta, they must have noticed that both of them offer some advantage as well as some disadvantage. And in general we can draw a few conclusions, like star winding is suitable for high voltage side or handling high voltage. Delta winding, high line voltage, while delta winding can delta winding is suitable for now. In case of three-phase, we can write our power in two ways. One is 3 V phase, I phase, cos theta. This is for balanced load. And another way of writing the same thing is root 3 VL IL cos theta. Now here I would like to advocate for this particular formula because quite often you will find that either of these two signal value, like either V phase is difficult to find or I phase is difficult to find out. Like, let me tell you one case. Suppose if you have a star connected network and you can like the network is enclosed inside a closed chamber, like it is a transformer winding, and no neutral is available to you. In that case, it is difficult for you to measure the phase voltage, but you can always connect a voltmeter between two phase lines and always measure the line voltage, and also you can always connect one ammeter in series with your line and measure the line current, and in that way you can find out the VL and IL. And same confusion will arise if you have a delta winding that is enclosed inside a closed chamber and you have no access to the winding, then you will not be able to find out IPH directly. Rather, you can find out IL, and then you can using this root 3 VL IL cos theta, we can find it out. Now, why star winding is suitable for handling high line voltage? Because those who have read this that scanned PDF must have noticed that VL is root 3 V phase. So even if you have a higher voltage, only 1 upon root 3, typically 86.6% of that voltage, not 86.6, sorry, I made a mistake, it is 57.7% of your line voltage will appear across your phase winding. Like if you have 415 here as your line voltage, you will find this will be probably 230. So that is the case. Here you have a chance to so it is another important thing here is that, like star and delta, when you will connect, you can have different phase shift between them. I'll discuss it in detail. Now what I'm trying to say here is that so now here one thing I would like to make it very clear. So we have 3-phase 4-wire connection we can have, or 3-phase 3-wire connection. One advantage of having 3-phase 4-wire connection is that availability of neutral point, and you can use it for getting the phase voltage directly without any other mechanism. Now here first I will study the different features of different transformer connection patterns, and then we will study that their suitability for different application. Which one is suitable for generator voltage step up, which one is suitable for transmission purpose, which one, not which one, rather the which connection pattern, right? Now one thing I would like to mention here is that it is the phasor group. Here, okay, before I proceed, I would like to mention one more thing, that you can have either a 3-phase transformer or a bank of 3 single-phase transformer where you connect the primary and secondary of each of the individual transformer in a definite pattern to form either star or delta across their secondary winding. And the beauty of this thing is that here one thing is very clear, that even if your primary winding is in star, if you change the interconnection in a correct manner, you can have delta across or delta formed by your secondary winding connection, right? So there is some problem in my system, my computer, so I have to stop sometimes. Now, where the first arrangement, that is one complete three-phase transformer setup, it is more compact and rugged in nature, but the second option, that is three transformer bank of three single-phase transformer, that is advantageous from the perspective of reliability. Like what I am trying to mean by the reliability, suppose some faults develop in your three-phase transformer winding. Then, although it is only phase means winding problem takes place on a particular phase, but you will have no other choice than to disconnect the entire transformer unit from your operating system, and then you have to carry out the maintenance, and once again you have to reconnect it. But what happens if you have a three single phase transformers, they are connected in form of band. Suppose one transformer develops a fault, and you can isolate the faulty transformer and let the two remain transformer remain operating, and by for certain configuration we can also do that. Like instead of three healthy transformer, we can serve the load, a reduced amount of load with two healthy transformers. And even if you have if you do not have that provision of that load reduction, you can do what? You can just take out that faulty transformer and replace it by a healthy transformer. And just taking out one single phase transformer is quite easy than that of taking the whole bulky three phase transformer out of your system. So it gives us this advantage of reliability and ease of maintenance, and that is why most of the times we prefer transformer bank than that of single three phase transformer. Now, in case of a three phase transformer, what we can have is like we follow the clock convention. What is that clock convention? What is that clock convention? Here, what we will do, we see your transformer will have high voltage and low voltage side. The common practice is denote the high voltage terminal by capital like A, B, C, and corresponding low voltage terminal by small a, b, c. And also what we do is that, where is the cursor? What we do that we consider, like what is clock convention? We draw a clock. Is there any option of drawing circle? Okay, so this is the border of our clock. Now what we will have here, we will have our high voltage line phasor. Now obviously high voltage you are having 3 phasor, but for a balanced connection these 3 are like, if you have star, your high voltage is star, it is A, B, C. If it is balanced, and your low voltage side is A, B, C, then we can consider the high voltage side A and we can draw the minute hand. That minute hand denote the HV phasor. Now what are the possible connection we can have? For delta we use D. If it is a high voltage side then capital D. If it is low voltage side then small d. For star we will use capital Y for high voltage, small y for low voltage, and for we have a third type connection that is known as zigzag. We denote it by Z. If it is on the high voltage side then capital Z. If it is low voltage side then small z. Now what are the typical type we can have? We can have either our high voltage and low voltage means perfectly aligned with each other. Then we can write that this is our hand and this is our minute hand that denote your low high voltage setting, like, okay, let me use some different color. This is our minute hand. Minute hand is for like you can write it in that clock. Roman clock are very good looking, so I prefer to write it in Roman. Now among these, what are the possible configuration we can have here is that we can have both of our minute hand and hour hand, they are perfectly aligned. Like this hour hand indicates our LV winding. So they are perfectly aligned and we call it 12 o'clock configuration. This is not only true for star, for delta also you can have it. For delta zigzag also we can have it. Now what is the other one? Like what other we can have phase sequence? Like we can have the low voltage winding. Just if you use DD and YY, like your both sides are having same connection pattern, only you just alter the polarity. How to realize that I will show you in detail. Just to alter the polarity, then what will happen? It will become this. So what we write, first condition when we had both aligned, this condition we can write for start star. Sorry, I just deleted that one. For the first condition, when you are both aligned, you could write it like y0. So what that y0 indicate? Y0 means both of your primary, or rather your high voltage and low voltage side will not use primary secondary, rather we will use high voltage low voltage side, because primary secondary is kind of means it is not a very technical term to use to refer your transformer winding. Once in an interview question I was asked and I said primary secondary, so that one panelist told me that how to define primary winding secondary, why are you talking like a labor or some illiterate person, why are you not mentioning it is high voltage and low voltage? So I found his point logical, because in some application we may need to step up, in some application we may need to step down. So there is no such definite primary and secondary, or rather it is very difficult to indicate primary secondary, but it is easier to have our high voltage low voltage winding. They are very definite and they won't create any confusion. So our high voltage low voltage, when they are aligned, we can write it y0. The same thing you could have if your the same thing you could have for delta also. If this is your ABC, it is your delta, and you have another ABC here, then you will get, you should write it like DD0, right? Now in case of delta we can also have zigzag. Zigzag is somewhat complicated, so I will show you later. Now when I have drawn delta, let me do it for delta first. So it is A, B, C. That means our phase sequence remains same. There is only just a phase alteration. Then what we will get? Since the low voltage side is exactly 180° phase apart, it will point. Your high voltage side cannot move from that 12. It means your minute hand has to you have to keep your minute hand at a particular position, that is at 12. But your hour hand can move. And hour hand, in case your low voltage is exactly 180° out of phase with your high voltage, it will have DD6. Right? Then what we can have, if we consider the star case, then what we will have? Then it will become YY6. It must be noted that if your primary and again primary secondary, not primary secondary, rather if your high voltage low voltage both of are having same connection pattern, that is either they are connected in delta delta or they are connected in star star, in that case you cannot have any other clock setting than that of 0 or 6. Like you can have DD0, DD6, YY0, YY6. You can't have any other clock setting. Now again we need to investigate that what are the other common clock setting we can have for balanced operation. For your information, let me tell you other 2 point that is possible is these 2 point. How we can reach that? Suppose your this one is having, you are having star connection, but due to some of your means you want to connect your secondary in delta, and that is quite often we do it. So if we connect it like this, so here what will be the position of your hour hand? So what you can write, your high voltage is in star, your low voltage is in delta, so YD1. Similarly, if you have something like this, then we will have, my drawing is not perfectly correct, if your secondary is in 30-degree lead to your no, not secondary, rather your low voltage is 30-degree lead to your primary, then we will have dy, sorry, small y 11. So in short, what I was trying to tell, first of all, three-phase transformer, star winding is suitable for high line voltage applications, delta winding is suitable for high line current application. Then you are having the advantage of 4-wire connection is that availability of neutral point, so you can easily find out the phase voltage or easily connect any appliance that is suitable for single phase voltage level, so you can connect it readily without any other additional arrangement. And then we have our clock convention, how we denote our prime. Okay, oh sorry, forget. I forgot it to mention that we are having, we can have three-phase transformer, or other way we can have three single-phase transformer to form a transformer bank. Transformer bank reliability is good. It is easy to repair, so most of the time we prefer transformer bank than that of a single three-phase transformer unit. Then I told you that about clock convention, generally we designate the high voltage side phasor by capital letters and low voltage side phasors by small letter. And if the high voltage side is connected in delta, then it will be capital D. We always mention it in D. Now high voltage side in clock convention, we denote high voltage side using our minute hand, and that is always pointed at 12th position. However, the hour hand can change its position or orientation with respect to the minute hand. If both of our high voltage and low voltage are at same phase, then it will give us 0 like DD0 or YY0. Or else what we can have, the primary and secondary are exactly 180 degree out of phase, high voltage and low voltage side, and in that case we can have DD6 or YY6. Do remember that DY6 or DY0 is not possible. You can't have that. And similarly, you can only have DY1 or DY11, but you cannot have DD11 or YY11, right? So with this, let us move to the next section where we will study the details of each individual connection. So here, first of all, we will consider the case where there is a zero phase displacement between HV and LV. So what we can have here, like we can have either we are going to study DD0, YY0. So here, as we are considering the transformer bank case, so first the transformer whose let me draw a simple transformer. So instead of drawing the coil, let us see, this box is a transformer, single phase transformer. This is our high voltage side. This is our low voltage side. So you also know the polarity. Suppose they are having subtractive polarity like this. So what you will have? You will have here, if you are going to connect these two with your A phase winding, see what you need to connect. Like you will have A1, A2. Here it will be small a1, small a2. Similarly, for transformer B, you will have B1, B2, small b1, small b2. Similarly, for transformer C, you will have, this is the first step, that is why I am drawing the individual transformer. After that, I will not draw it in this way. So, what you will have here basically, how to connect. Like, forget about transformer. If I give you 6 resistor, right? 6 resistor, if I give you, like you have RA, RB, RC. This is A1, A2, B1, B2, C1, C2, and you are having so if that is the case, then what you can do here, is that if I ask you to connect delta delta, then what you can do? You can connect so basically you have connected A1, B1, C1 to form the neutral point, and A2, B2, C2 you can connect with your three-phase supply, right? This is will be connected to your three-phase supply, three-phase high voltage supply. Now you are having, you can do the same thing for this. You are connecting A1, small B1, so in this way you can connect a start without any phase shift. Now the same thing we can do for three-phase transformer. Like we can represent the transformer winding in this way. What we are looking for? We are looking for this when we are talking about, we are looking for this. So what you will have here, you will have your primary winding. So let us name it A2, A1, B2, B1, C2, C1. Now what you do, you just short them to form the neutral wire. And you are having, in secondary also you have A2, A1, B2, B1, C2, C1. So what you can do, you can also short them. And this will give you the low voltage side 3 terminals. These are the high voltage side 3 terminals, or including neutral 4 terminals. These are the low voltage side 4 terminals, right? Now in case of delta, what you will have, in case of delta, you can write it like first of all, what about delta? How to form it? You will have sorry. This is your delta. Now, what we can do? We can connect this, the point with A2 with A phase, we can do that, and similarly we will have do remember one thing always in your mind, that for balanced delta you need to connect A2 with either of C1 or B1. You should not connect A2 with B2, then it will be problematic things. Now, if we draw the winding, then what we will get here, if we want to realize dd0, where is the dots? Then it will be so how you can do that? Here A2, A1, B1, B2, C1, C2. So what was the connection pattern? We should connect, just scroll it. A2 should be connected with C1, and A1 should be connected with B2. So A1, B2, A2, C1, B1, C2. Now if you follow the same for your secondary, like A2, A1, B2, B1, C2, C1, and then start connecting them like then you will get dd0. Now this is the case, and also we can have probably we have reached the end of this page. We can have dz0. dz0 is a very interesting connection. Please note that this z is for zigzag or interstar connection, it is known as. So if you try to connect it in that dz pattern, what you need to do, like all the primary and secondary transformer, here you have to assume at least your secondary, as the secondary is we are going to connect the secondary in zigzag, all the secondary must have a center tap. So what is that center tap? What do we mean by that? Here we are having our primary, that is right. However, in case of secondary, it is not like this simply. It is Like here you have a tap, you can connect A3 with A2 to form this complete winding, or you cannot. But rather you have a provision that if you don't want to connect them, then you can leave them open or connect them in different way. Like not center tap, rather to say that you are having in secondary it is two winding are present. Generally, if you connect them in normal start, what you should do? You should short A1, B1, C1, and also short A2, A3, B2, B3, C2, C3, and A1, B1, C1. You will get YY0 and also delta. But if you want delta zigzag 0, then what we need to do here? First, we need to draw the phasor diagram. So, as we are going to connect it in delta, so let us draw it. Let me draw the phase lines like or if you want, you can draw it in this way also. It will save some of our space. Right. Now, let me draw the corresponding secondary. Right. Now, what we can do, let us start. What is the phase of this A? It is like you can join the vertex with the centroid of this equilateral triangle and you will find the phase. Right, this is the phase. So this is our in. Right. Now, how to connect them? Okay. So let me start. Perfect. Three. Okay, so here now it is somewhat clear. We can proceed. See here, I have drawn the segments. Now let me move it one by one so that you can also follow. I wish I could zoom it. Let me try. Sometime my touchpad works, sometime it doesn't. Anyway, okay. Yeah, finally. So what we can do here is that let us take this segment. Here. Fine. See, try to understand that I am not altering individual phase orientation. C3, C4 was there, I just parallelly shift them. Now, what I will do, I will connect that C3, C4 was there, I just parallelly shift them. Next, I will do what? Better not to shift C3, C4. Let us take this one. Just a minute. Yes, not C3, C4. Why not C3, C4? I will tell you later. Let us take this C1, C2. So what is important here that I am not altering any phase sequence. What it was there in space, means what is its orientation. I just allow it to as it was, its initial orientation was. So I just connect this C1, C2 with A3, A4. Now what we need to do here is that let us connect. Okay, let us move it sidewise, otherwise it will. Yeah. Now perfect. Oh God. See the beauty that we are having. I wish I could minimize it. Sometimes my touchpad works, sometimes it doesn't work. Anyway, so what I am trying to show you here is that a very interesting thing. See that I have connected all A2, B2, C2 here to form our neutral. So let me draw it once again because I am not able to handle my computer cursor quite well. So the way I just connect them, what was that? Initially it was here A3, A4, A2, A1. Then here it was uh, like C1, C2, C3, C4, and here it was B1, B2, B3, B4. So what I planned that A4, B4 and C4, they are corresponding to our the high voltage terminal, sorry, fine. Yeah. So these A4, B4 and C4, they are corresponding to A2, B2, C2. That is why we have to keep them as our uh, connection terminal. Now let us check whether we are able to maintain the orientation or not. Let me join the A phase with neutral point, B phase with neutral point and C phase with neutral point. You will see that they are maintaining the orientation. Right? So if we try to realize this in terms of these, then how should we join? A3 should be joined with C1. So A3, C1, A2, B2, C2, all these three must be shorted to form the neutral of our interstar, not capital N, small n, like no, the neutral for our interstar. Now, what is B3 should be connected with which one? B3 should be connected with A1. And C3 should be connected to B1. So hopefully you find it pretty complicated and already got confused. Let me quickly repeat it, this DZ0 once again. This is DZ0. What we have? We have our high voltage side in delta, how to form the delta? And corresponding we are having here so what we can do here, Let us draw the phasor diagram. And correspondingly what we have here, right? So what we need to do first, connect then move it aside. So what is the voltage phasor? You can view it like A, B, C. Here also C. Right. So this is our dz0. This forms our neutral point of the secondary side. So all this for today. Next practice.